Good morning, students. Our today's topic in the circular mirror is problems involving arc length and area of sector. And here is a question. The diagram shows a sector OQP. So OQP is a sector, center O with a radius R in a right angle triangle. So radius R in a right angle triangle. So this sector is in the right angle triangle with QRO is equal to theta. So QRO here is theta in the radians. Show that the area of the shaded region is given by, so area of shaded region is this one. So we have to prove this. So look now, actually this is sector and it is the angle at the origin of the sector. So let's suppose it is theta. So look now, or it will be like pi by 2 because the sum of the angles of the triangle is 180 degree, you know. So 180 minus pi by 2 minus theta. So it means this will be pi by 2 minus theta. So the requirement is area of the shaded region. So we have to prove this. Okay. The first part is show that the area of the shaded region is given by r square over this one. So first part, so shaded region is required, so that will be equal to area of triangle minus area of sector. So first we are going to find the area of sector. So area of sector OPQ will be equal to 1 by 2 r square theta. 1 by 2 is there, and theta, the angle subtended at the origin of the sector is pi by 2 minus theta. So pi by 2 minus theta. So this is the area of the sector. Now in the triangle, actually this is the angle given in the triangle. So this perpendicular is given and base is missing. So in triangle OQR, okay, tan theta is equal to perpendicular over base. Tan theta will be equal to, perpendicular is R and base is QR. So QR will be equal to R over tan theta. So this is the base now, and now the area of triangle. Area of triangle OQR will be equal to 1 by 2 into base into height. So 1 by 2 base is QR and QR is R over tan theta. And height is R. So it will be equal to R square over 2 tan theta. Okay. Now we can find the area of the shaded region. Area of shaded region, that will be equal to area of triangle minus area of sector. So area of triangle is this one, r square over 2 tan theta minus area of sector. And here is the area of sector, that is 1 by 2 r square into pi by 2 minus theta. Okay, solving it further because we have to prove this equal to this one now. So solving the bracket. So r square over 2 tan theta minus of 1 by 4 pi r square minus plus 1 by 2 r square theta. Okay. Now we have to prove equal to this one, r square over 4. Okay. So over 4. Okay, multiply and divide the full equation by 2. So it will become 2 r square over 4 tan theta minus 2 over 8 pi r square plus 2 over 4 r square theta. So we have multiplied the full step by multiply and divide by 2. So we can take r square over 4 common now because r square over 4 is there with every value. So r square over 4 is common now. Okay, from here 2 over tan theta will be left minus r square over 4 is common. So the remainder will be minus pi. So minus pi will be written later and plus 2 tan theta. So r square over 4. So plus 2 theta. So this is proved. So first part is done. Now in the second part, if theta is equal to 0.77 and r is equal to 10 centimeter, find the perimeter of the shaded region. So look now, shaded region. So this is the arc length. This side is QR. Okay, QR is here. So this is the second part. So QR is r over tan theta. R is equal to 10 and theta is 0.77. So 10 over 10, 0.77. So first change your calculator into radian mode. So 10 over 10.77. This is 10.31. Okay, this side is done. Now arc length. Arc length. S is equal to r theta. Radius is 10. Theta is 0.77. So 10 into 0.77 will be equal to 7.77. So this is also done. Now this is the thing which is left. There, that is PR. Okay. From this triangle, we will find full length. So look now. In triangle OQR, so perpendicular over hypotenuse, OQ over OR, perpendicular over hypotenuse sine theta, so sine theta is 0.77, perpendicular is R, that is 10, Our hypotenuse is OR. So OR will be equal to 10 over sine 0.77. 10 over sine 0.77. So this is 14.37. So this is OR. Now PR is the requirement. So PR will be equal to OR minus OP. So actually PR is the requirement. Okay. OR minus OP. So OR is 14.37. OP is radius, that is 10. So this is equal to 14.37, 4.37. So now we can find the perimeter. So look now, required perimeter finally. Alhamdulillah, we have reached. So perimeter will be equal to PR plus this side plus this side. So PR is 4.37 plus this side QR. So where is QR? Here is QR 10.31 and plus the arc length, that is 7.7. So adding this on the calculator, 4.37 plus 10.31 plus 7.7 equal to 22.38. So this is the perimeter of the shaded region. Here is another question. The statement of the question is the diagram shows two sectors OAB and OCD. So here is OAB and here is OCD. Okay. Center O and AOB is 2 radian. So it is 2 radian at the center. Given that OA is equal to 5 centimeter. Okay, it means OB is also 5 centimeter because that is the radius of the smaller sector. And area of the shaded region is 39 centimeters square. Okay, find the length of the AC. Okay, this is the requirement. So suppose we let this length X. This will be X as well. So because area of the shaded region is given, so actually this is the key point. So we have to move up to area of a shaded region. Then we will be, okay, the first part was length of AC. That is easy one. Okay, no. This is AC, so we have to move up to the area of the shaded region. So look now, first part, area of sector OCD. Formula will be 1 by 2 R square and R will be 5 plus X into theta. Theta is 2 radians. So 2 will be cancelled by this. So this will be the remainder thing. Okay. First write it as it is because it will be open later. So centimeter square is the unit. Now the area of the smaller sector. Area of sector OAB. Again, the formula used will be 1 by 2 R square theta. 1 by 2 R square is 25 and theta is 2. So 25 centimeters square. Okay, now the area of the shaded region can be find out. So area of shaded region. will be equal to area of bigger sector minus area of smaller sector. So here is the area of bigger sector, that is 5 plus x whole square, minus area of smaller sector, that is 25. Okay, now this bracket will be opened by applying the formula of a plus b whole square. So look now, 25 plus x square plus 10x minus 25 will remain as it is. From here 25 will be cancelled, and area is x into x plus 10 centimeter square. So this is the area of the shaded region, because area of the shaded region is given, that is 39. So x into x plus 10 will be equal to 39. Okay. Actually, we have to solve it by factorization or some other method. So x square plus 10x minus 39 equal to 0. This is a quadratic equation. Okay, from here solve this triangle by factorization. Multiply the coefficient of first one with the last one, that is 39. Central coefficient is 10. So think a pair of numbers whose multiplication equal to this one, addition or subtraction equal to this one. So the numbers will be 13 and 3. So x will be written with both of it. This sign is telling us that both signs will have opposite sign. This is telling us that greater will have positive and smaller will have negative. So now put these values in place of this one. So x square plus 13x minus 3x minus 39 equal to 0. From here make pairs, take common. So x into x plus 13. From here minus 3 is common, x plus 13 equal to 0 is still there. The bracket which is common will be written once, and the values outside the bracket will be written in the next bracket. Equal to 0 is still there. From here x will be equal to minus 13 or plus 3. This will be not applicable because length cannot be negative. So x is equal to 3 centimeter. The first part was length of AC. So AC we have let x, so it means first part is done. This is equal to AC. Okay, the second part is the perimeter of the shaded region. So look now, second part, perimeter of shaded region will be equal to this side plus smaller arc plus greater arc. So 3 plus 3 plus smaller arc will be s is equal to r theta. So 5 into 2 plus greater arc, s is equal to r theta, because x is 3, so r will be 8 for the bigger sector. So 8 into 2. Solving it further, so 6 plus 10 plus 16. So 16 plus 16, 32 centimeter is the perimeter of the shaded region. So this is the answer. Here is another question. The diagram shows a semicircle PQR, center O, with radius R, okay, radius R, and POQ theta radian, POQ theta radian, okay. In case theta is equal to 1.5, calculate the perimeter of a sector QOR over perimeter of sector QOP. Okay, so look now, first part, perimeter of QOR, perimeter of sector QOR over perimeter of sector QOP. Okay, so QOR over QOP. Okay, if this is theta, so definitely this is total pi, so this will be pi minus theta. Okay, perimeter of QOR will be equal to S is equal to R theta, so R into theta is pi minus theta over QOP, that will be S is equal to R theta, so R theta. From this step, you can see R will be cancelled. So pi minus theta over theta. And in first part, it is given that theta is 1.5. So now solving it, pi minus 1.5 divided by 1.5. So it is 1.09. Okay, this is done. In second part, given that the area of the sector QOR, that is bigger sector, is twice the area of the sector QOP. Okay, show that theta is equal to pi by 3. Okay, first we have to prove it. So look now, in second part, area of sector QOR is twice the area of sector QOP. So 2 times of area of sector QOP. So now solving it, area of bigger sector will be 1 by 2 r square theta. So 1 by 2, radius is same, that is r square, and theta is pi minus theta. On the right hand side, area, this 2 is remain same, and 1 by 2 r square theta. Okay, 1 by 2 will be cancelled on both sides, and this r square will also be cancelled. So on left hand side, pi minus theta will be left, and on right side 2 theta will be left. So this theta will go to the right side, it will become 3 theta. On left side, pi will be left, and theta will be equal to pi by 3. So this is one thing done. Okay. Now further look, it is given that for this value of theta, that is theta is equal to pi by 3, show that the perimeter of QPR. So look now, QPR is actually the perimeter of semicircle. So the perimeter of the semicircle will be R plus R. So perimeter of QPR That will be equal to this full side plus this plus this. So look now, OP plus PQ. So R plus R. Okay, putting values directly, that will give you the answer. Okay, R plus R, this side PQ. The arc length is here, that is theta, pi minus theta. R into pi minus theta plus this side plus this smaller, that is QOP arc length, and here is the arc length, that is R theta. But before proceeding, look students, I have not placed this R plus R because the requirement was perimeter of the sector. I have not placed this R plus R and in the denominator as well R plus R because 2R will be cancelled by this one. So the ratio was same. That's why I have put only this thing. So you can put also that thing here, that is R plus R over R plus R. The effect will be almost same, almost same. So that's why I have not placed it, so to make it simple. So okay, moving further from here, so this is 2R plus R into pi minus theta is now pi by 3 and plus R into pi by 3. Okay, now solving it, pi minus pi by 3, pi minus pi by 3 will be equal to 2.09. So 2R, okay, the requirement is in terms of square root, so we will not solve it. Okay, 2R plus R into 3 pi minus pi, 2 pi by 3, and here is R into pi by 3. So actually we have to come here, that is this thing. So if you look, R is common throughout, so remainder will be 2 plus 2 pi by 3 plus pi by 3, and R is common now. From here it will be 6 plus 2 pi plus pi over 3 into R. So if you solve it, this will be equal to this thing, 3 plus square root 3 into R. So this is the answer.